Alright class, today we're doing geometric sequences. Where arithmetic had a common difference, a geometric sequence is a sequence with a common ratio. And what that means is the terms go up by multiples. So if I have this sequence here, 1, 2, 4, 8, 16, hopefully you guys notice that every time I'm multiplying the next term by 2. So my ratio would be 2. So to get a common ratio, you take one of the terms, we'll call that the current term, and you divide it by the one right before it, or the previous one. So 16 divided by 8 is 2, 8 divided by 4 is 2, so on and so forth. Is 3, 6, 12, 14 a geometric sequence? Well, if you pause the screen, you can think about it, or if you just look at it, it's multiplied by 2, and then it goes up by 2, adding, which is not. So no. You have to have it always be going multiplying by something. So, because 12 to 14 is then a multiple of 2, or multiplying by 2, it is not a geometric sequence. Now, just like we did before with proofs, we have to prove without using, like, putting numbers in. So to do that, you need the next term in the sequence. So that means you put an n plus 1 in wherever you see an n. So I'm going to put an n plus 1 here. Okay? Then I'm going to show that the common ratio is always constant. So remember, the ratio is the current term, which we just found, divided by the original term. And if you remember correctly, if you have the same base, you subtract the exponents. So 4 to the n plus 1 over 4 to the n plus 1 minus n is just 4 to the first. Since this is a constant, then we can say it is always geometric. Okay, so that's the proof there. And just like the notes from before, we also have these three terms that we want to be geometric. So again, this is the third, second, and first. In order for this to work, the third term over the second term, that ratio, has to be the same ratio as the second over the first, because again, it's geometric, so the term in front of it divided by the term behind it has to equal, again, that second term over the first. So to set this problem up, we're going to say x minus 68 over x plus 16 equals x plus 16 over x minus 12. That's a 12. So, next thing we're going to do is we're going to cross multiply and FOIL. So you're foiling these things together and these things together. We'll write it out over here. X plus 16 times x plus 16 equals x plus oh, there's no pluses on that side, x minus 12 and x minus 68. Okay, then you FOIL. So on this side we get x squared plus 16 is plus 32x, and then 16 times itself is 256. On this side we get x squared, then we get minus 80x, and then 68 times 12 is 816, and that's going to be a positive. So the nice thing here is you should note that the x squareds will cancel, so this isn't actually a quadratic. These will cancel, so now we just move our x's over. 32 plus 80, you get 112x. If you move the 256 over, you get 560. And then if you divide that by 112, you get x equals 5. So x would be 5 to give us a geometric sequence. Let's just double check that. Put 5 into all of these. 5 minus 12 is negative 7. So I get negative 7 for the first term. 5 plus 16 is 21. 5 minus 68 is negative 63. And sure enough, you should be able to see that this is multiplying by negative 3 each time. That is a geometric sequence. So to find the nth term of a geometric sequence, you need the first term, and then you need to just multiply that by the common ratios, and you need, like, let's say I want the fifth term. To go from the first term to the fifth term, you need 4 ratios. So you always need as many ratios as one less than the term you're looking for. And that's how we write that. Find the 11th term. So the first thing I need to do is I recognize what kind of sequence this is and what I have. The first term is 3, and these are multiplying by 4, so r equals 4. So the nth term is 3 times 4 to the n minus 1. Do not multiply the 3 and the 4. You cannot do that. Please don't do that. This is not 12 to the n minus 1. It is just 3 times 4 to the n minus 1. So this would be called your nth term. Then we need to find the 11th term. The 11th term is 3 times 4 to the 11 minus 1. So we get 3 times 4 to the 10th, which is a really big number. 4 to the 10th times 3, you get 3,145,728. Okay? There we go. So that would be the 11th term. You can also find the sum of the first n terms of a geometric sequence. Now this formula is a lot more, you have to use induction to prove it and stuff. We're not going to prove this one, we're going to just give this one to you. It's the first term multiplied by the quantity of 1 minus r to the n over 1 minus r. Okay. Now, to do this formula you need to identify the first term, which is 9. And you have to identify r, which is, you're multiplying by 3's. The only problem is we need to know what n is for this one. We need to know what n is. So to do that, first thing you should do is do the nth term formula that we did on the other page. I know my nth term formula is this. But I know I want to know what n is when I have the term 6561 on this side. So the first thing I'll do is divide by 9. So 6561 divided by 9 is 729. And then remember, when you're solving these problems, you could use logs, but 729 is a multiple of 3, so you just have to figure out how many 3's it is. It's actually, if you look in your calculator, try it out, this is 3 to the 6th, which is 3 to the n minus 1. Now you can set your exponents equal, so I get n minus 1 equals 6 or n equals 7. Now I know what n is, I can do my sum of the first 7 terms. It's the first term, which is 9, times the quantity, 1 minus 3 to the 7th over 1 minus 3. So 1 minus 3 to the 7th. This becomes 9 times negative 2186 over negative 2. And when you do the final calculation, the sum of the first 7 terms is 9837. So that means if you add up all the terms in between, that's what you would get. Alright, so that is how you do geometric. Tomorrow we're going to look at converging and diverging infinite sums. And that'll be it for sequences and series. I will see you later.